Okay guys, everybody's favorite, sigma, and how you use it to find area under a curve. So we're going to calculate or estimate area under a curve. When I say under the curve, I mean between the curve and curve meaning the equation or function and the x-axis. It's not necessarily under, it's between the function and the x-axis. So it's going to be an estimate. We're going to use rectangles. So the problem I've given you today is f of x equals x plus x squared. That is the function we're looking at. We're looking on the interval from 3 to 8. And we're going to use 4 left endpoint rectangles and 4 right endpoint rectangles to do it. So here's how it's going to work. We are looking at basically the area from those 2 dotted lines from here to here. So everything right there. What's going to happen basically is we are looking at first figuring out how wide the interval is, and you're going to subtract the endpoints. And then you're going to split that into the number of rectangles. So we're going to divide 5 spaces, 5 units divided by 4 rectangles, and that's going to give us 1.25. What that's giving us is the width of every rectangle. A left endpoint rectangle, basically, you start at 3. That's the first point of the interval. You draw a line up to the curve, and then that's going to be the left side of the rectangle. We would call that coordinate x0. So the very first coordinate would be x0, and that x0 is going to start at 3. The next coordinate would be exactly 1.25 units away, which would be 4.25. So the next rectangle is going to start at 4.25. So I'm going to estimate that here, and I'm going to draw a rectangle. I'm going to stop it right about there. There's 4.25. Just deal with it. That's what it is. All right, so that's 4.25. That's going to be x1. Then x2 is going to be 1.25 away from that, which is 5.5. And x3 will be plus another 1.25, and that's going to be 6.75. x4, which is your last rectangle, you're going to add 1.25 one more time, and you are going to get 8. That wouldn't make sense if it were 7. These two should be the beginning and end of the intervals, and they are, so we did all our work right. Now, if you're looking at the graph, you're just going to kind of do that. So at x1, we already did that. x2 is 5.5, so about halfway between 5 and 6. Let's be like right there. We're going to make another rectangle. Okay, and we're going to go straight up to the axis. And then where's the next one? 6.75, so maybe a little closer to 7. This is not to scale. We're going to connect like that. And then the last one would be at 6.75. Oh, we just did that, I'm sorry. Now, 8 goes all the way up there. If we were to draw a left endpoint rectangle there, we would have to go off the edge of the interval. We only want to look from 3 to 8. If we drew a rectangle, it would be hanging off the edge. So in our calculations, we're not actually going to use a calculation at 8. We're only going to use these 2, and these 4. And if you look, we have 1, 2, 3, 4. So this is going to be an underestimate because there's going to be gaps missing right there. So instead of doing, and then what we're going to do is we would plug in the 3, plug in this, plug this in, plug this in, plug this in into the equation, get a bunch of y values, okay, and we'd find length times width, length times width, length times width. We add all that up. Very tedious. To save time, we're going to plug all these in simultaneously by making a formula. The very first value we start with is the number 3, and then we continuously add plus 1.25, our width. Okay, so this first number in the interval, that will always be right here, and the width of each rectangle will always be this, and we're going to say x because we're going to do it multiple times. If we put in a 0, which is right here, we get 3. Put in a 1, we get 1 for x, we get 4.25. Put in a 2, you'll get this. Put in a 3, you'll get this. We're not going to put in the 4 again because that's going to be hanging off the edge. So when you do this, you will not be using the last coordinate. I'm going to leave that up for a reason. You'll see why. So that's what we're going to do. This is the thing we're going to plug in. We're going to plug this in for x in our original equation. And it's going to look like this. So our original equation was x plus x squared. We are going to now plug that in, and it's going to look like this. Instead of x, we're going to have 3 plus 1.25x plus x squared. We're going to have 3 plus 1.25x quantity squared. That, when we plug that in, it's going to represent our y values. This is basically all of my heights for each particular coordinate. Okay, so we're going to add all those heights up. How do you add a bunch of heights up? You write summation notation. You put a sigma right there. We want to plug in a 0, a 1, a 2, and a 3, these numbers right here. But we don't want to plug in the last one, so we're going to say x equals 0, but we're not going to plug in 4. We're going to go to 3. So it's going to go through 0, plug in a 1, plug in a 2, plug in a 3, and it's going to stop and terminate. And it's going to sum all of this up. You're going to want to put parentheses around the entire thing. All right, so that's what we're going to sum up in our calculator from 0 to 3. Fun fact, the number on top for left endpoint rectangles, this is always one less rectangle. This is 4 rectangles minus 1. That will always be your top index when you're talking about left endpoint rectangles. So that's always going to go there. And then that would be the sum of all of the y values, all of the heights. To find area, we need to multiply this height, this height, this height, all of these heights by the width, which is consistently 1.25. We're always going to use 1.25, so what we can do is we can factor it out and just multiply by 1.25 there. This is the formula. This is how you're going to do sigma notation. You're always going to do it this way. All right? And I'm going to calculate that right now. So if I calculate that interval, or that sum I should say, we are going to get 152.969 approximately. That would be the approximate area under the left endpoint rectangles. Pretty cool? All right. Now what we're going to do on top to get the right endpoint rectangles, the process works the exact same way. I'm going to redraw in pink. The right endpoint rectangles, you're literally going to do the same thing, but the lines that hit are going to be the right side of the rectangle. So when we do 3 and we hit the curve, if we want to make that the right side, it would actually hang off the left end. But it's outside the interval, so we're not going to use this one this time. So if I go to 4, it's going to go up to there, and it's going to hang off there. So that pink one is the right endpoint. Here's another one. That's the right side. It's going to go like that. Right side, go like that. This time we are actually going to use this because now this rectangle is not hanging off the edge. So the pink ones are your right endpoints. There are 4 of them. And again, we are going to have to skip this first one. So we're not going to use x0, but this time we're going to use x4. Equation, very simple. It's almost identical, 1.25. And this sigma, remember, this is going to sum up. This is going to sum up all of our plugins. We're plugging in all of these x values. So it's summing up our y's, or our heights, if you will. Oops. All right, so everything's the same. The only thing is we're not going to use 0 to 3 this time. We're going to have to use the number 1 and end at 4. The numbers we put here have nothing to do with the interval we're looking at, just so you know. So 1 to 4, and now when we plug those in, we're going to get our answer. So I am going to put that in my calculator. And I get an answer, well, it's pretty big. I get an answer of 227.969, approximately. All right? And there is our right endpoint. And obviously it is an overestimate because these are all hanging out above, so you're getting a little bit extra. And it's bigger than that one. If you want a better estimate, we could always average these out, and that would be basically how you do a trapezoid. It's like just for fun fact. All right, so fun fact of the day, there it is, area under the curve. I know we love it. Good luck.